welcome to grade 11 college math, and we're in unit 3, personal finances, and this is lesson 5 on the operating costs of a vehicle. So one of the largest costs of vehicle, the largest cost of a vehicle is the purchase. However, the entire time you own a vehicle, you will continue to pay additional payments. When owning a vehicle, you must be prepared to spend money that you will never see again. You'll never see a return on. So vehicles are really they definitely depreciate, and you don't get your money back. Now there are the rare occasions where there's antique vehicles. So at this point, we're going to go through some notes that are pre-typed, and we'll just discuss them. And later on, we'll get into the math behind some of the costs of owning a vehicle. The operating costs. You have some fixed costs. These would be an expense that remains the same from month to month. A varying cost would be an expense that varies in the amount or frequency. List the fixed and variable costs related to owning and operating a vehicle. So you can think about those things. Think about a few different examples, and we'll look at this chart. So some of the fixed costs will kind of go back and forth either side. Well, usually your car payments are fixed costs because they're a regular thing you do each month. A variable cost would be your tires. You're going maybe back and forth between an all season and a dedicated winter or summer tires. And so you could be switching your tires, which has a cost to it, having them removed and put back on. Your insurance payments are usually done a monthly payment, or maybe once a year, but those are fixed costs. They don't tend to vary. They set a price for you for the whole year, and then you stick to that price. Regular maintenance. So you could have it as that where you bring it for regular service or regular oil changes. However, at the same time, you could have unscheduled repairs or unscheduled maintenance costs. Things like car washes, little day-to-day maintenance things you might, or week-to-week maintenance changes. Your gasoline costs are variable because very few of us drive the same amount every week. Okay, so when insuring a vehicle, you have there's an important term called a deductible. This would be the portion of the claim that has not been covered by the insurance company. So usually you have to pay a deductible to have the work initiated and for the insurance company to go through with the claim. So it could be $500 or $1,000 on any damage or theft that's happened to the vehicle. So sometimes your your deductible might not be worth paying to fix a minor thing. So here we have Ralph, and he is single. He owns a 7-year-old mid-sized car. He called several insurance agents, and the lowest quote he received was $2,600 per year. There are two payment options. He can pay the insurance premium in full once a year, or he can pay it as a monthly installment of $230. So let's compare what it would cost to calculate the annual cost if he chooses the monthly installment. So we will say okay, so we'll have the total, the cost will be the monthly payments times the number of months. So we have 230 times 12 will be 2,000 $760. Calculate the difference between the two payments. Well, the higher number is the monthly value minus the original for a year. Well, that's going to equal 2760 minus 2620, $140 difference. So therefore, he can save $140 if he pays the annual amount one time a year. Okay, suggest reasons why Ralph might choose each option. Well, choosing the one-time option costs less. Okay, choosing monthly provides more affordable payments, right? Paying all that money up front in one shot might be difficult, but spreading it over 12 months might make it more affordable. Okay, we're going to talk about calculating fuel costs. One concept we need to understand is fuel efficiency. Fuel efficiency is the measure of how far a vehicle travels per unit of fuel. Common units of fuel efficiency are, well, in Canada we use liters per 100 kilometers when we use this unit, or in the United States they might use miles per gallon. So we have a scenario here of Devon's truck. It has a 70-liter tank and a fuel efficiency rating of 11.8 liters per 100 kilometers. So here's just a question. We're going to go through these problems. Explain what the fuel efficiency rating on Devon's truck means. So it means under normal driving conditions, the truck will use approximately 11.8 liters of fuel to travel a distance of 100 kilometers. If the vehicle uses less fuel to travel 100, it will be more fuel efficient. On our sheet, we have a few math problems to work out fuel efficiency, so we'll do that together. Let's figure out how far Devon's truck can travel on one fuel tank. So I like to use a proportional statement. Here's the problems. So I like to use a proportional statement anytime I'm doing problems like this. So we can say that blank to blank is equal to blank to blank. And we're saying liters per kilometer is equal to liters per kilometer. They've given us information that says 11.8 liters for every 100 kilometers. You know that he has one tank of gas of 76 liters, but we don't know how far that can go. So now we put this into a proportion with 11.8 over 100 equals, it's liters over kilometers equals liters over kilometers. All right. Now we cross multiply these. Okay, remember how to cross multiply. We're going to bring this up. We're going to bring this one down. And we're going to bring this one up. So what's that going to look like? Well, we have x all by itself coming up here. 76 is already here. It's going to be multiplied by 100. And on the bottom, the 11.8 came down here. So we have 76 times 100 bracket 11.8. Okay, so x will equal 644 kilometers. Therefore, the truck can travel approximately 644 kilometers on one tank of gas, of fuel, let's say. Good. Now, next we can say how much fuel would his truck use on a 450 kilometer trip? Well, again, we're going to use the fuel efficiency rating. So again, we have this rating of 11.8 to 100 kilometers. In this case, now we know the kilometers at 450, but we don't know how many liters it will take. So do the same pattern that we did before. 11.8 over 100 equals x over 450. Now there's not as much cross multiplying we need to do. So we're just going to bring one thing up, and that's going to isolate our x. So x equals 11.8 times 450 divided by 100. Well, let's bring that over here to our calculator. 11.8 times 450. Yeah, that's okay. Divided by 100 equals 53.1 liters. Okay, so it will take about 53 liters. Therefore, it will take approximately 53 liters to travel 450 kilometers. Good. So the next question says, explain how to determine the cost of the fuel for a trip in part C. Well, we would have to be given some information. So if we were to look up fuel costs today, let's say they were 99 cents a liter, right? Then we could do, we were going to take information from before. So let's say the cost of gas will be 53 liters times the current gas prices. So for example, say example 1 here. Let's say we had 53 liters times 99 cents, but that's turned into dollars. So we would have, it's going to be, well, 99 cents is a dollar, so it's not going to be very interesting actually. 53, but that's what the price was when we did this video. Okay, 99.9 100, and you're going to get 52.95. Sorry, 52.95. In other words, $53 because it was basically a dollar. So let's do a different example because that's not going to help you out very much, guys, by seeing an example like this. Let's do one where we have more expensive. Let's say we had $53 and back in the summer during, well, not this summer, but maybe during tourist season, they put the prices up, or some of the other provinces have more expensive gas. So let's try $1.13. So 53 times over 100 because you're converting cents into a dollar. And so this one is more interesting. So it's going to cost us 59.94. Right? And we could keep trying different examples, but that's basically how you'd find the solution. Sorry, I didn't put that over 100. All right, good. What else do we have for costs of a car? Cost for a vehicle is its depreciation. The depreciation is the amount that the value of an item decreases over time. It's often thought that a car depreciates the minute you drive it off the lot, in other words. So you purchase it, it's a certain value. The minute you take it home, you cannot resell that car for the same amount you just bought it for. At least the dealership won't take it back for that much. So the car depreciates quickly in the first few years and then levels out a bit. Okay, so a new mid-size vehicle sells for $21,000. Marizia researched used cars of the same model and found the following information. Below is a chart. So useful formulas for calculating depreciation. All right. So depreciation amount is the new car price minus the depreciation value after X amount of years. Or you can use depreciation amount is the depreciation percent times the new car price. So usually you're given one of these information, or you're given that information so you can apply it. Here's some other ones. The depreciation value after a certain amount of years. Well, the value of the new car minus the depreciation amount. So maybe you'll know how much it depreciated by, and you can figure out how long that, how the value is affected by how many years. The depreciation percentage, right? It'd be good to put it in a percentage, like, oh, my car is 57% worth what it used to be. So the depreciation amount divided by the car price times 100 to put it into a percentage. Okay, let's now try some of these depreciation values. You'll notice there's a bit of a trick to this because it's giving you missing information. We start off with the depreciated value. So what can we do with this? Well, if we have the depreciated value, which ones could we use? We could use depreciation amount here and the value of the new car. Those are two things we already know. We don't know the percentages yet because we don't know how much it's been depreciated by. Okay, so let's work this way. So we're going to work this direction. So here we go. We have the value of the new car, 21,135 minus 16,000 equals 5,135. Now that we know the depreciation amount, we can find out the percentage because this is what we needed over here. Now we know the actual depreciation amount and the new car. So this is going to help us with that question. So we're going to say the depreciation percentage equals 5,135 divided by our original amount, times 100 to put it into percentage. Let's plug this in. So 5,135 divided by 2,135 times 100. So we have a percentage of 24.3%. So in 1 year, if we were talking about this, in 1 year of owning the car, you will lose 20%. It's not like if your car lasts 10 years, you're going to lose 10% a year. In that first year, you lose a bigger amount. So what is the car now worth? It's now 16,000. So it went from 21,000 to 16,000. It lost a quarter of its percent. All right, how can we use this information to help us here? Right? So what we can do is the easiest way is probably going this way. Okay, and we can go the original amount, 21135 minus, this is how much we're deducting. And now we have a new amount, 21135 minus 8385, and our car is now worth 12,750. Oh. All right. So that kind of hurts, eh? It's not worth as much as it used to be. Now, what can we do this way? We want to know a percentage. Well, what did we do up here? Once we knew this value, we put it as the numerator divided by the denominator. So that can go up here. And we will have, again, the percentage will be 8,385 divided by 21135. Notice how this number accumulates. So in other words, in one more year, we've lost about 3,000, maybe less, to 2,800. Okay. So it's not as much as the first year, but it is significant. It's a good chunk of money. Okay, so how much has the car depreciated as a percentage? 8,385 2,135 times 100 as a percent, we have 39.7%. So our car is now worth 39.7% of what it used to be. All right, kind of sad. All right, how can we use this information then to figure out these other two columns? Well, I think we can probably relate this to the original amount. So if we were to say 21,135 times what is now it's worth less than 50% now. Only after 3 years it's less than 50%. That's why people want to buy a used car at the 30. That's why cars start going on the used car lots at 3 and 5 years. And the warranty sometimes is over by 3 or 5 years. Anyways, just a side note. All right, so that's 47.95. Okay, let's punch that in. Now we're doing it as a percentage, so 12135 times. Now we turn our 47 into 0.4795, and we get our car is now worth, or no, our car has been deducted by this much. So $10,000 have now been depreciated off the original cost. So what will be our new price? What's our new value of the car? 10,0134.23. Oh, all right. So 21135 minus, remember your answer button, right in there. 11,000. So now our car is worth 11,077. Okay, so it is slowing down. This was a bigger drop than this was, right? So we drop a lot in the first year, a little bit more in the next year. Okay, so where do we go from here? Well, we can do what we did over here. We did 21135 minus 9800 equals 335. This is how much the price has dropped from there to there. I mean, how much has been deducted. So this is the new price, but that to get that new price, we have to take 11,000 off of the original price. What's that going to give us? Just like following this model, we're going to get the percentage here. Oh, the percentage equals 11,335 has been taken off of 2135, and that gives us, we're going to multiply that by 100. Okay, so 1135 divided by 2135, and we're multiplying that at 53.6%. This is how much we've deducted. So we've now taken off over half the car price. And we can see that because 9,800 is less than half of the original price. So anyways, this keeps going until our car goes down and down and down in value. What's interesting is if we were to plot this, like you guys know exponential growth patterns. So let's say you said time or years and value. Will the car ever get to zero? Hypothetically, yes, but hypothetically, okay, we start our car here. It drops very fast, and then it starts to slow down, and then maybe it never touches zero. Because what do we learn about exponential in Unit 1 is sometimes it never touches there. It might just be worth. So someone will give you $100 for your car. Someone will give it to you for $300. Even if you bring it to the junkyard, they might give it to you for parts. So, it's never totally worth nothing. Even if you donate it to the school board for the auto classes to use, sometimes they'll give you a receipt worth $350 or something like that. Don't quote me on that, but that's what I've heard in the past. Okay, so that's the cost of operating a car. Certainly there's more. Certainly there's more things to consider, but those are kind of the introductory um, things that you might think about when you're operating a car after you own one. All right, thanks for following along. See you next time.